If you're new to machine learning with TensorFlow, you may have been surprised at how challenging it can be to get TensorFlow installed properly without errors in Windows, particularly if you're using a GPU-enabled version. In this tutorial, I'm going to take you through 3 different ways to install TensorFlow in Windows, ranging from a very simple method to more advanced. Let's get started. So I know that this one is cheating a little bit, but for many of you just getting started with TensorFlow and machine learning, it's actually probably one of the best options for you, just because it's so simple to use. This is Google Colab, which is short for Collaboratory. And it's actually a cloud-based version of a notebook environment for Python, TensorFlow, and you can actually install any other machine learning packages that you might want to use as well. The reason I say cheating is because it actually doesn't require you to install TensorFlow, Python, or any other packages for that matter on your own computer. It's all run in cloud, and for that reason, it's very easy to use and easy to access for most people. So I've put the link for Google Colab in the description below, but when you launch it, it comes up with this welcome page that actually has some really useful tutorials and information about how to use the system. I won't go through that here today, but as you can see here, there's a getting started, some very simple examples to start, but then it actually goes into more detail on some of the more advanced things that you can do on the platform. For today though, what I've done is I've just created my own notebook here to walk you through how to actually use TensorFlow on the system. So I'm going to open that here for you now, and I've actually included a link to this notebook in the description as well if you want to follow along. So one of the great things about the notebook environment is it actually allows you to use 2 different types of blocks. There's text blocks, which I've shown up here at the top. These let you explain what your code is doing and add any notes or other information about your project. And then there's code blocks, which are these black blocks you see down a bit further. These let you break up your code into chunks, and you can actually execute these one at a time and see the output as you go. So one of the other cool things about Colab is that you actually run your programs on Google's cloud. I know that not everybody has a latest GPU from NVIDIA on their computer, so this is actually one way to run more advanced models without the need to go out and buy those. You can actually go up to Connect, change runtime type, and this is how you choose what type of processor you want to run your program on. For early and quite simple machine learning models, you can actually just keep that on CPU. If you want to run that on GPU or Google's TPUs, which are much faster for larger models, you can choose those options here. Google does include some free credits for you to use depending on the workload of their servers. These are shared servers. But for any serious processing, you'll have to upgrade to their paid plan that gives you more compute units, which you can see down here. For this example, we're just going to leave it on CPU. So I'll just choose that and click Save. And then you just hit the Connect button up top there, and that'll connect you to the compute resources. Now that we're connected, I'm just going to quickly run through the rest of this notebook to show you how to import TensorFlow and then use it to run some code. This first statement, as you can see here, just imports the package. You can run any of these code blocks just by hitting the play button next to them, or Shift F10 actually does the same thing. For this next code block, we're just going to print out the version number to show that it actually imported properly. And we can see that we're actually running TensorFlow version 2.15. In this next code block, we're actually just going to define a small neural network and run that to show you how TensorFlow works. I'm not going to go through the code and actually how every line works, but just to show you that it actually can run a small neural network. So we'll run this block, and this actually just defined the structure of the model and outputs the number of parameters in the structure. We've got 3 layers in the model, 2 hidden layers and 1 output layer. In this next code block, we're just actually going to use NumPy to produce some dummy data. And then we're going to fit the model using that data. So it's a very small model. It runs very quickly with 10 epochs. Training is complete. And now that we've got a model in place, we're actually just going to generate some additional dummy data and to run a prediction. And there you go. So that's it. That's really all there is to running TensorFlow in Google Colab. Colab has pretty much any machine learning package that you probably want to use built in already. I'll show you, for example, how to import scikit-learn and matplotlib. You can import those. If you want to see a full list of all the packages, you can actually just run a pip list with the exclamation point there to run it. And as you can see, there's hundreds of packages already installed. So for this next example, I'm going to show you how to install TensorFlow natively in Windows. I'm going to show you how to install both the CPU and GPU versions of TensorFlow in Windows. But just to note that the last version of TensorFlow that supported the GPU on native Windows was 2.10. In a different method coming up, I'm going to show you how to install the latest version of TensorFlow with GPU support, so stay tuned for that. The first thing that you need to do is to install the latest version of the Microsoft Visual C++ Redistributable. I've included the link to this in the description below. But you just come to this page, scroll down until you find the installation packages, choose the one that applies to you, and it'll download, and then you run that. I already have it installed on my computer, so I'm not actually seeing the install button here, but if you don't already have this installed, run through the process and then you'll have it. The next package that we need to install is Miniconda, which is just a minimal version of the larger package called Anaconda. I've included the link to this in the description below. You just come to this page, click on the Windows installation package, that'll let it download. And once that's complete, you just click on the package to run the installer. I'm just going to accept all of the defaults. Now that we have Miniconda installed, there's a PowerShell that's been added to the Start menu. So if we go down here and just type Mini, that should bring it up. That opens up a terminal for us. And the first thing that we want to do is to create a development environment for our TensorFlow installation. So we're going to use the conda create. We'll call it tf-cpu because we'll be installing the CPU version of TensorFlow first. And then we want to specify that we want to use Python version 3.9. So we'll just go ahead and execute that. That will go ahead and collect the package information. We'll go ahead and click yes to do the installation, and there it is finished. The next thing we want to do is activate the environment. So as it shows there, we'll just go ahead and run conda activate tf-cpu. And now anything that we do is going to be executed within this environment. So that protects the rest of the system from any packages that we install causing problems with anything else that we're running on the system. The next thing we want to do is to make sure that we've got the latest version of pip installed. So we're going to run python -m pip install upgrade pip. And now we're ready to install TensorFlow. So we're just going to go pip install TensorFlow. And that will go through and collect all the dependencies, download TensorFlow, and install the latest version into our development environment. So let's just run pip list. That'll show us all of the packages that have been installed. And as you can see here, we've got TensorFlow 2.16.1 installed right now as of the recording of this video. Let's go ahead now and just test the installation. We'll go ahead and start up a Python interpreter, and let's just verify that we can actually import and use TensorFlow. So let's go import TensorFlow as TF. This will go ahead and produce some warnings. They are just warnings and don't actually impact anything that we'll be doing here. But it looks like it did import. Let's just check by printing out the version. And we can see there we've got 2.16.1 installed. All right, and now let's just run a TensorFlow method to make sure that it's working properly. So this just created some random data in a matrix and run a sum across the matrix to produce a tensor. So it looks like it is working properly. All right, so I've exited out of the interpreter, and now what we're actually going to do is just run a Python script from the command line. So I've actually just made a Python file with the same neural network that we ran in the Google Colab Jupyter Notebook. So this code you can actually download from a link in the description, but all I'm going to do is change to my working directory, and we're just going to execute that script just to make sure that it's working properly. And as we can see, the script runs properly, so we've got TensorFlow installed.
Now I'm going to show you how to do the same installation but with the GPU version of TensorFlow. As a starting point, I'm back to where we had just finished installing Miniconda.
The first thing we're going to do for the GPU installation is to create another Conda development environment. So we'll go ahead and go Conda create. We'll call this one tf-gpu. And again, we want to specify version 3.9 of Python. So once that's done, we'll go ahead and activate that environment. And again, we want to make sure that we've got the latest version of pip installed. So we'll go python-m pip install upgrade pip. Oh, I made a mistake there. One of the differences between the GPU and CPU versions of TensorFlow is that the GPU version needs some additional packages from NVIDIA. So we'll go ahead and install those now. So once those NVIDIA packages are installed, we'll go ahead and install TensorFlow. The difference this time is that we want to specify that we want version 2.10 of TensorFlow, which is shown by the less than 2.11 in what I've got typed on the screen here right now. All right, let's just run a pip list. And as we can see, we've got TensorFlow 2.10.1 installed. Let's run a Python interpreter, and let's just verify that we can actually see the GPU from TensorFlow. I am going to show you how to avoid those warning messages that we were getting before. So we'll go import OS, and then we're going to say os.environ tf cpp min log level equals 2, and that will turn off the warning messages that we were seeing before. So now if we go ahead and import TensorFlow, and then we run a version, we get the version number without all those warning messages we were getting before. So the way we actually verify whether TensorFlow can actually see the GPU or not is we run this statement here. So that will list any GPUs that TensorFlow detects. If you get a blank response, that means it hasn't detected a GPU, meaning you either don't have a GPU or it just hasn't been able to detect it. Let's exit out of the interpreter again, and let's just run the Python script that we did before with the small neural network just to make sure that it works properly. And it looks like it is. So that's how you install both the CPU and the GPU versions of TensorFlow in Windows native environment. So remember, for the GPU version of TensorFlow, in Windows native, the most recent version that works is TensorFlow 2.10. So if we want to use the most recent version of TensorFlow, which at the time of this recording is 2.16, we need to use a different method. The way to do that is to use WSL, which is an acronym for Windows Subsystem for Linux, and that's the method that I'll show you how to do now for both the CPU and the GPU. What this does is it actually installs Linux in parallel with Windows, so you've actually got both operating systems working at the same time. And WSL is essentially a virtual machine that's developed by Microsoft that allows Linux to run concurrently with Windows rather than having to use a different method like a dual boot or a dedicated virtual machine, for example. So what we're going to do first is go down to the search bar and run PowerShell. So this is the Windows PowerShell this time, not the Anaconda one that we installed previously. And the command we're going to run is just wsl --install. This will go ahead and install WSL if it hasn't been already, and also by default install the Ubuntu Linux distribution. So once it's installed, it's going to ask you to make a username and password. This is different from your Windows username. And it may ask you to reboot at this point. It's probably a good idea to do so anyway. If you have rebooted, I'll go ahead and show you how to relaunch the terminal. So we'll just close out of this one. All you do is you go down to the search bar, type in Ubuntu, and you should see an option here to launch that. The next thing we want to do is just make sure that we have the most latest version of all of the packages within Linux. So we'll go sudo apt update. And this will go ahead and update any packages that have been made into a newer version. So we're actually going to install the Docker container version of TensorFlow. To do that, we're going to first download the installation script using this command here. That'll download the script into our working folder, and then we'll go ahead and install Docker with this command here. You can just go ahead and ignore that warning that it's putting up on the screen there right now. We actually do want the Linux version installed. Let's just verify that it installed properly, so we'll run docker version, and we should see a version number there, which we do, so it has been installed properly. Next, we just want to do some cleanup on the users that have access to it, so we'll go sudo group add docker. Next, we're going to run this command to add our current user to that group. Once we've done that, let's go ahead and exit out of this shell and relaunch. So we'll close that out, relaunch Linux. Let's just verify that Docker is working properly. So we're going to just run a sample script here called hello world. And it looks like it's working properly.
At this point, we have a choice to install either the GPU or the CPU versions of TensorFlow. I'm going to show you how to install the GPU version first, but this is also the starting point for when I come back to show you the CPU installation afterwards.
The next thing we need to do is to install the toolkit from NVIDIA. So to do that, we'll first set up the repository, and I'll put this actually down in the description below so you don't have to try to type this out yourself. Then we'll go ahead and do an apt-get update. And then finally, we can go ahead and install the package itself. All right, the next thing that we're going to do is to configure Docker to actually use that toolkit. So we'll run this command here. And that will go ahead and create a configuration file that Docker can use. Once that configuration is complete, we need to restart Docker, so we'll do that with this command here. And now let's just verify that Docker has access to the GPU. So we'll go ahead and run that with this command here. All right, and what you're looking for here is, first of all, that it can actually see both a driver and a CUDA version here for you. So now we can actually go ahead and launch TensorFlow from a Docker container. And the way that we're going to do that is with this command here. And if you haven't actually already run this before, it'll go ahead and download that Docker container and then execute it. Okay, so that'll launch a shell inside of our container. Let's go ahead and run a Python interpreter from within the container. And again, I'm just going to go ahead and turn off those warnings that we had before. Now let's go ahead and import TensorFlow. And let's just print out the version number to make sure it's imported properly. And as you can see, we've got 2.16 installed. Let's just verify that it can actually see the GPU. And we can do that again with this command here. And as you can see, we've detected the GPU, and that's how you have TensorFlow installed with the latest version and GPU access in Windows. Let's exit out of the interpreter here. And remember, we're still inside the container, so let's go ahead and close out the container. And next thing I want to show you is how to launch TensorFlow with the CPU only version, if that's something that you want to do. Very similar, just run a slightly different command to launch it. And now we're in the CPU only version of TensorFlow. So one thing to remember about working with these Docker containers is that anything that's changed or saved within the container is actually lost when you exit. So what I want to show you how to do now is how to actually access files from your Windows computer within the container so that you can have persistent storage. First thing that we'll do from within our Linux is run explorer.exe with a dot to denote the current directory. That will launch a Windows Explorer in our home computer. What I'm actually going to do now is actually paste a file into that folder. So I've got the simple NN Python script that we had used previously. And now if we do a listing within that folder, we can see that that file is actually available to Linux. Next, what we want to do is actually launch a Docker container mapping this folder into the container. And you can do that with this command here. And now we're inside the container. If we do a directory listing within the container, we can see that we can actually access that file here as well. So let's just go ahead and run that script from within the container. And as we can see, it's working properly. So that's it. That's all of the installation methods for TensorFlow in Windows that I'll be showing you here today. Hope that you found this helpful. Please let me know in the comments below if there's anything else in the future you'd like to see along these lines. And please like and subscribe. Thanks, and see you again soon.